Hello everyone and welcome back. Today we're going to be learning the conduction system of the heart. I like to call this the heartbeat generator. So the reason your heart is beating is not the love of your life, it is the conduction system. Anyways, I digress. Before we go into the conduction system of the heart, I would like to give you a gross overview of the chambers of the heart. So the heart is made up of four chambers. We have the right atrium, the right ventricle, left ventricle, and the left atrium. The right atrium collects deoxygenated blood from the vena cava, the superior and the inferior vena cava. The right ventricle pumps this blood to the lungs to get oxygenated. The left atrium collects oxygenated blood from the lungs via the pulmonary vein, puts it into the left ventricle, and the left ventricle pushes this blood out through the aorta. This is basically the functions of the chambers of the heart. If you don't understand what I've just said, you can check out my video on blood flow through the heart. I will put the link in the description box below and you can check it out. You will be able to understand what I've just said a lot better. So moving on to the conduction system of the heart. The conduction system is basically a group of cells or nodes which generate electrical pathways that controls the heartbeat. When we talk about the heartbeat is the contraction and relaxation of the atria and ventricles. Atria is the plural version of atrium. If you hear me mentioning atria in this video, I'm talking about the left and the right atrium. So the contraction and relaxation of the atria and ventricles is what is called the heartbeat. So what triggers this contraction is the conduction system. So the electrical impulse generated by the conduction system causes contraction of the heart. So the conduction system is made up of 5 key parts. We have the SA node, which is called the sinoatrial node, the AV node, otherwise known as the atrioventricular node. Then we have the bundle of His. It further goes down into the left and right bundle branches and ends at the Purkinje fiber. Moving on to the sinoatrial node. The sinoatrial node is called the primary pacemaker of the heart. It is the main generator of electrical impulse. So it triggers this electrical impulse and transfers it down to the rest of the conduction system. In cases where the sinoatrial node has issues and is not able to trigger an electrical impulse, the AV node can also trigger an electrical impulse, but it generates at a slower rate than the sinoatrial node. The sinoatrial node fires at about 60 to 100 beats per minute, and that is the basis for the normal heartbeat. So the normal heartbeat is within the range of 60 to 100, and that is because that is the normal firing rate for the sinoatrial node. When this electrical impulse is generated by the SA node, it is transferred down to the AV node, and it moves down through a collection of tracts known as the internodal tracts. We have about 3 of them: the anterior, the middle, and the posterior internodal tracts. You can see them in this diagram here. The impulse is also transferred to the right atrium through the Bachmann's bundle. So once this impulse is transferred, the atria starts to contract, and the contraction leads to the ventricles, the left and right ventricles, filling up with blood. When the impulse reaches to the AV node is just situated just at the base of the left atria. When this impulse reaches the AV node, it is delayed for about 0.1 second, and it is delayed because the ventricles need time to fill. So the body does not want a situation where the ventricles are pumping out blood when it's not completely filled. That would lead to an inefficient pumping of blood, and the body does not want that. So it resolves this by delaying the contraction once it gets to the AV node. Once the ventricles are filled up, the impulse is transferred down to the bundle of His. And from the bundle of His, it moves down through the bundle branches to the Purkinje fibers, which triggers a widespread contraction through the ventricles, through both ventricles. The ventricles are contracting simultaneously. It is not a situation where the left ventricle contracts and after that the right ventricle contracts. They are both doing this at the same time. So as the left ventricle is pumping out blood to the aorta, the right ventricle is pumping out blood to the pulmonary artery to get oxygenated, and the cycle continues. So the key takeaways from this video is that the sinoatrial node generates the impulse. It transmits it to the AV node where the delay happens to allow the ventricles to fill. The ventricles, once they are filled, the impulse is transferred to the bundle of his, further down through the bundle branches and the Purkinje fibers, triggering a contraction of the ventricles. Secondly, the SA node fires at about 60 to 100 beats per minute. Now, in a situation where the SA node is having problems and is unable to trigger an electrical impulse, the AV node can take over in order to sustain life, but it fires at a much slower rate of 40 to 60 beats per minute. Sometimes, in very severe cases, the Purkinje fiber can also trigger heartbeats, but it's a lot more slower at about 20 to 40 beats per minute. So when you hear that someone has a pacemaker, that pacemaker, the artificial pacemaker, is basically replacing the sinoatrial node. If the person is having an irregular heartbeat continuously that is not being corrected by other factors that could cause it, if there is a problem with the SA node and the heart is misfiring, then they would need the artificial pacemaker. If in the generation and transfer of electrical impulses, there is a fault in any of the parts of the conduction system, that affects the contraction and the relaxation of the heart, leading to inefficient pumping. Let me give you an example. The AV node, we've learned today that the AV node delays the impulse to allow the ventricles to fill. If the AV node starts to have a problem and is unable to delay this impulse and just fires once the electrical impulse gets to it, the ventricles contract and pump blood without actually filling up, leading to problems. So what kind of problems would this lead to? It will lead to inefficient blood supply. And then the person will be feeling faint, feeling dizzy. And that's when we talk about things like a cardiogenic shock. We'll talk about this in another video. So these are the significant things to pick up from this video. As always, if you have a question or if you're confused at any point, kindly drop it in the comment section and I will reply to clarify you. Thank you so much for joining Chronicles of a Learner today, and I hope that you've learned something useful. Let me know in the comment section. Don't forget to like and subscribe so that when I post a new video, you would know. If you need a picture of this pamphlet where I have represented the diagram and the key facts, the reason that this pamphlet is very important is that once you get it, you can quickly look at it at any time. You can access it anytime to remember what you've learned today. This pamphlet is available on my WhatsApp channel. The link to this will be in my description box below. Kindly click on it so you can get this and save it, or you can get this and save it for future purposes. Please share this video to whoever you know would need it. If you're a nursing student or a medical student or a healthcare professional who just enjoys being knowledgeable about things going on in the body, you're very much welcome to my page. On Chronicles of a Learner, I simplify anatomy, physiology, and pathophysiology. And if you have any questions, please let me know. If there's a system that you would like me to talk about, kindly let me know in the comment section and I will talk about it. I will simplify it for you. Again, thank you so much for watching and I will see you on my next one. Bye.